Knowing about tools GUI and its shortcut keys are so important to make design process efficient. In this video, I'll give you detailed overview of Cadence OrCAD's PCB Editor 17.4. We will start from creating design areas, part placement, board outlines, design constraints, some routing tips, and very useful shortcut keys. So let's get started. Let's open PCB Editor 17.4 first. And for creating a new board file, we'll go to File, click over New, and make sure you are selecting correct drawing type. In our case, it will be board. And for drawing name, so before that, let's browse for the location where you wanted to save the board file. In my case, I'm going to save it in desktop. And board file name, I'm going to choose demo. Click over Open and OK. Now it is asking to create some design changes. As of now, we are going with the default one and click on OK. In the next step, we'll create netlist from Capture CIS schematic that we have created in the last video. For that, we have to go to Tool and click over Create Netlist. And here you have to select where you wanted to save the netlist file and click over OK. As you can see, the netlists are successfully created. Now before importing the netlist on our board file, we have to add few directories on user preference. For that, go to Setup and select User Preferences. And here you have to select Library. And inside the library, you will find two options. One is pad path and another one is PSM path. So pads path is a directory where we save footprints and their pad stacks. And PSM path is the same directory as pad path, because when we save footprint, it create a PSM or .psm file. So we have to locate that as well to import the netlist successfully. So let's click over this one. I'm just going to delete one and create a new path. And it should be the same path where you are saving all the pad stack and footprint. Just select that. OK. And another one is PSM path. Just select that as well. OK. Click over Apply and OK. So we have added the directories where we have all the footprints, their pad stack and PSM files. Now we have to import the netlist. For that, click over Import Netlist. And from here you have to select what should be the import logic type. So in our case, that is Design Entry CIS or Capture, and leave all other things as default. And now you have to select the import directory. So in our case, this is our import directory where we have imported the netlist. So just choose it and click over Import. You can also verify through this command window. So here it is saying the netrev completed successfully and we are not getting any error. So if you can't able to see command window here, what you have to do, you have to just go to Display, go to Windows and select command from here. Let's hide the command window first. Now we'll start with first way of component placement. To do that, we'll go to Place and Components manually. And here we can see all the three components that we have placed on our schematic page. We can either select them one by one or multiple together and place them on board file. For now, I'm just going to place them randomly. Then later we'll arrange those. Now we have to place R1. Next, you can just close it. And I'm just going to tell you how you can navigate through this board file. So first is using scroll wheel, you can able to zoom in and zoom out the components or board file you have created. So to navigate around, either you can use arrow keys, left, right, or up and down arrow keys, or you can just press the scroll wheel to navigate around the board file. Let's suppose I wanted to change the position of origin, which I wanted at the corner of the board, somewhere here. So as of now, it is somewhere in this board. To change it or to place it at a particular location, what you have to do, you have to just go to Setup, click over Change Origin, and wherever you will click, that will be your new origin for the board file. So I'm just going to place it somewhere here. There is one more way to arrange these components as per schematic file. So what you have to do, firstly we'll split the screen. So let's select your board file, and using Windows and arrow key you can split it, and this is our schematic. So let's suppose I wanted to arrange these components as per schematic, and we have so many components in our schematic. So in that case, firstly you have to just click over place components manually, alright, and just select connector. So as you can see now, connector is on my mouse cursor and I can place it anywhere I want. So let's suppose I placed it here. Similarly, you can arrange registers and other component. So I wanted to place registers here and LED little bit away from register, like that. Okay, so this is also one way to arrange or place components instead of placing those manually. Let's close it and maximize the board file. Now we are going to change the grid size. To do that, we have to just right click, quick utilities, and click over grids. And here we have a couple of options. So either you can change for non-edge or all edge, or separately for top and bottom. In our case, we're going to use 5 mil for non-edge and 10 mil for all edge. So let's do that quickly. Click over apply and OK. Now in the next step, let's talk about how we can change the size of designators. So as of now, you can see each component has very thin designator and size of the text is really big. So to change it, there's two ways to do that. First is you have to just firstly off all the filter and select text from here, just holding the control on your keyboard and select all the text. Right click, you can go to change text block to anyone you want, and similarly you can do for other type of text. Just select it, or you can simply just drag and select all together. Right click, change text block to first. So you can see we have changed the size of the text. So let's suppose we wanted to put our own text shape and size. For that, what you have to do, you have to just go to setup, click over design parameters, and here you have to select text and click over setup text sizes. You'll see all these text block. So as of now we are using first text block, and why it is so thin, because the width of the text is 0 here. So let's make it 5 or 4 mil. Alright, and whatever you are using you can do that, or you can add your own text block. Click over OK, and as you can see that the text width is increased now. So you can place it by selecting all these text together. So assembly top we generally place over the component, and designator we place outside the component. So let's do that quickly. So as of now we have placed the reference designator, and we got to know how to use text block for each text. Now let's hide the pin number. So if I zoom in a little bit, you can see these pin numbers are there, which is not useful for our case. So to hide these pin names or pin numbers, we have to select color dialog, go to geometry, go to package geometry, and from here you can hide the pin numbers. Click over apply and OK. So as you can see, the pin numbers are gone now. Now we're going to create a board shape here. For that, go to shape and select rectangle, and we'll go to options here to choose correct class and subclass. So in this case, for board geometry, we have to select board geometry from class drop down menu, and from subclass we have to select design outline. As of now, I'm just going to leave it as default. We'll start from origin and we'll just drag it around the components. Right click, done. So we have placed the board outline now. Now in the next step, we're going to add key pin layer. To do that, you have to just click over outline, select Z copy, and from drop down menu, you can select key pin, and here you can enter the offset. In our case, either you can add 5 mil or 10 mil. So I'm just going to create a key pin for 10 mil. And you have to select the design outline to create a key pin 10 mil inside that. So just click over this one, and as you can see, the key pin layer is created now. You can just simply right click and click over done. Now let's set up some design rules and constraints. As of now, if I'm going to place the connection or routing, it will use default wire thickness and default constraint. So for example, using F3, you can do that. So as you can see, it's just picking up the default line width. But to change or add your own design constraint, you have to just, so I'm just cancelling it. For that, open Constraint Manager. And here you have to just go to Physical Constraint. And under this, you can create your own constraint set. So for creating your own constraint set, you have to just click over DSN, right click, and select over Create Physical CNet. Let's name it Demo and click over OK. So under Demo Constraint Set, I'm just going to put some constraint or minimum or maximum value of line width. So till here we have created the constraint set, which is demo. Now we have to assign this constraint set to different nets. Let's suppose I want these line width for power nets only, but for signals I want little bit thinner, or 5 mil, or if you are following some impedance properties, then that line width will be depends on the impedance. As of now, we're going to assign this constraint set to different nets. To do that, you have to select all nets here. As of now, you can see the default constraint set is assigned for 5 volt ground and LED A net. So if you wanted to change that, you can change it to demo. So I'm just going to change it for demo. Alright, and close it. So let's try again. Just select the pad and press F3 on your keyboard, and you can see the line width is 10 mil now. And if I'll go, let's say more than that, because the constraint was it should be between 10 mil to 20 mil. So let's suppose I'm going for 25. See what will happen. So we are getting some DRC markers here. Right. So let's press Ctrl Z and let's create all those connections using 10 mil line width. Let's suppose between LED and connector I wanted to place a via. To do that, although it is a ground net, but I'm just going to demonstrate how you can place via easily. So firstly, you have to just select the pad, press F3 on keyboard, and just route where you wanted to finish on the top routing. Then right click and click over Add Via. So it will add via. Now you can route on the bottom layer. In the next step, I'm just going to demonstrate how you can add copper pore on the top and bottom. To do that, you have to just select. So there's one way to do it manually. So you have to just select the rectangle, and I wanted to place it on the top side, and you have to select the dummy net. Let's say it is a ground pore, and you can just start routing it like this. Alright, and from type, it will define either it will be a dynamic copper or a static one. If it is a dynamic copper, it will just follow all the constraint whatever we have set in Constraint Manager. So you can just select a particular area and just click over this. There's one more method to place copper pore. For that, go to Shape, select Z copy, and here go to H and select bottom layer, because on top layer we have already placed the copper pore. You have to select the Create Dynamic Shape. So how it will select the net name? So after filling all these detail, we have to click over the particular net, and that net will be the net for bottom copper pore. So for example, here we have filled all the detail. I want offset of 10 mil from the key pin, and let's click over this ground pore. If I click over this, you can say it will, the ground net will be automatically picked by bottom copper pore. Alright. To see that separately, we'll go to visibility and just hide bottom ones. So you can see this is our top layer and this is bottom layer. So this is how you can create your own board on PCB Editor 17.4. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.